Hello, everybody. Thank you. I hope you had a good lunch. And thank you again for showing up to libp2p Day. So I had on the schedule that we were going to do a SWOT analysis after this. We will do that, but I think we're going to try to make it the time compressed because this afternoon we have a couple of really great workshops that I think everybody wants to get to. So we're going to try to hold you as little time as possible so that we can get to actual hacking. I just want to introduce our panelists. So I had asked some of the maintainers that I know, that I talk to on the regular, but if you're a maintainer in the audience and you want to come up here, feel free. Because this community really is run by us. I know I keep saying that, but I'm going to keep saying it. I just want to introduce, so I got Ian. He's the PeerGOS guy, but he is also the JVM libp2p maintainer, one of them. And then Gui here is our Kademlia expert, but he's like sort of a jack of all trades, and he's getting more and more into Rust libp2p maintenance, but has done so in the past on Go libp2p. And everybody here knows who Alex is. I think Alex, he and a very small army of people single-handedly made JS libp2p into something totally awesome over the last couple of years. So I asked him to come up here just to give all of you an opportunity to ask uncensored questions of maintainers of libp2p. And so this is your chance to tell us we're doing it wrong or we're doing it right, or, if you have technical questions, we could field those too, but I think that would probably be better for the workshops that we're about to do here in the afternoon. So at this point, I just want to hand it over to the rest of you. I think, is there a question, Mike? I mean, I can work the crowd and ask questions, or I should probably just do that. So I'm going to turn it over to the rest of you. Do you guys have any questions? If you guys don't have, actually, you know what? Back up. I'm going to ask each one of you why you chose that libp2p implementation that you worked on, and where you see it going. Like, keep it to a couple of sentences. Like what's the highest priority on your list at this point? So we'll start with you.
I chose JS libp2p because I'm rubbish at Go. It chose me, I guess, from that perspective. I think where I want to see it going is I want to see like proper browser-to-browser, peer-to-peer applications being written. I want to see like WebRTC everywhere. I want to see that kind of like next level kind of app development. Like JS has a problem and a great strength in that it runs everywhere. So people are like, it's very easy to like focus on the browser quite a lot, but it runs in Node on the server, it runs in Electron for desktop apps. But the browser is kind of the one place it runs where no other implementation runs. So that I think is the focus.
Yeah.
So I started working with Go, and so that's where my focus was, and until recently where I started to pick up Rust and look at the Rust libp2p implementation and realize, so because I'm mostly focused on Kademlia, that there is some work to be done with the Kademlia implementation in Rust, and so that helped me pick up Rust, and so get more involved with the repo and looked at, other parts that also need work. And so the focus would be to address most pressing issues and also catch up to get more maturity and get more feature to match Go and JS implementations.
So your life wasn't hard enough, so you started learning Rust?
Yeah, it's always good to have challenges.
Yeah.
So I chose the JVM basically because PeerGOS is in Java, and for years we were using Kubo, and then later on Go libp2p. But all of those involved managing a separate process and crossing the language boundary and all this. And we just wanted an in-process thing which gave us more flexibility and more control.
So what is your top priority for JVM libp2p?
Better compatibility with the rest, with Go and Rust, and better speed, and better hole punting, and all the stuff.
Okay. All right, so I wanted to open it up to the rest of you. Do you guys have any questions for these guys?
So this is directed at you, Guy.
Okay.
First of all, where do you see Cicada going? When is it, you think, going to come to fruition and we're going to see it deployed? And what do you generally see as some of the challenges that we face in the current sort of Kademlia implementation of libp2p?
I'll start maybe with the last question. So the current set of challenges with Kademlia. So one is the number of RTT, and the handshake is a huge overhead at the moment, which means that for a DHT lookup, you need to open new connections to be able to find the content you're looking for. And to open a new connection with libp2p, you need to have the handshake process, and depending on the transport using, that's multiple RTTs. So I think Quick should solve that with the zero RTT handshake, or even when you do the first handshake. So that will be, I think, a massive improvement in terms of speed and also in terms of compatibility. So if we can, transport compatibility, if we can get those sub DHTs that I mentioned in the morning, one for each sub transport, then we can solve the DHT problems for nodes that use more unpopular transport.
So just to make sure I understood there, in the talk today that you proposed a sub DHT per transport, wasn't that just an emergent property of the reality today already, or is that something that requires active implementation?
So it requires some change in the way the DHT is implemented at the moment, because for now, if you have a transport that's not widely used, you still use the same DHT, so that there's just one DHT, and it will be hard for you to find other peers that speak the same transport, and so that's the difficulty.
Another question. Here, I got it. It should be. This mic.
1, 2, 1, 2. Okay, there we go. Yeah, so Alex did a demo yesterday with Chrome and Mozilla, and it looked like there was lack of compatibility still in.
That demo worked. The problem was that I was undone by poor UX. So what I forgot to do was click on the name of the channel. If I clicked on the name of the channel, the message would have arrived. I went outside and I was talking to people, and I was like, I think I just worked out why that didn't work. And I pulled out my laptop and I clicked the thing, and there was the message that had arrived. So I'm really sorry. That was my own fault. That was just me,
Okay.
I could vouch for that. I saw it afterwards. It worked.
Yeah.
So Chrome works then.
It worked, yeah.
Okay, and so then the reason that I brought that up is so there is a way to package up Chrome through Electron, right? So it's a desktop app. So the question is then, do you think whatever current version of Electron is, if it'll package up the right version of Chrome for libp2p to work? That's one question. The other one was Turi is kind of the competitor for packaging up same thing in browser, where you could still use React to build your app and compile it to a desktop version. Are you guys familiar with Turi as another alternative to Electron?
No, I haven't tried that, but I will say that we run all our tests against Electron, against the main thread, in Electron. So we should be completely compatible. I don't think we're testing on the very latest version of Electron. I think there's a problem with the test runner at the moment. But I think the latest version is 30, I think, and we're testing 27. So there shouldn't be any compatibility. So we don't use any the only places where we use node specific code is in things like the TCP transport and that. We try and use standard JavaScript APIs at all times. So as long as the deployment target doesn't as long as I don't end up using any crazy code, it should be fine.
Okay, and so in your demo with the pub sub, it's you post something, the whole chunk shows up. Is there a way to establish socket channels so that it's live? So for example, if you're streaming Olama where it's coming in on the socket connection, is it possible to forward that onto another browser in real time as opposed to waiting for the whole thing to complete?
How do you mean whole thing to complete?
Oh, how do I mean? So let's say you're doing inference and it's pumping out text, a couple of words at a time. Can you send it as it's streaming, or does it have to come in the whole big chunk? Is there a socket just reading bytes or pushing bytes on one end and having it come out the other end? Does it libp2p support that, or does it like here's a package and it needs to show up on the other end?
I'm not sure I understand the question, but libp2p streaming it's all streaming. So if you're sending big chunks of data and it's taking too long to send smaller chunks.
Okay, so that's just build it. Like I said, you put in a message, you hit something, and then like the whole thing showed up. So anyway, so that answers that question. Another one is, if you're using Node, would it be possible to implement an HTTP server that's full file system and doing kind of browser to browser requests? Is that a thing?
Yeah, of course.
And then with that, how does encryption work to do like exchange public-private key and that comes through? Or is that something that you guys have dealt with as far as serving up the pages that way?
Well, if you're signing a web server, it's just general Node APIs. If you're doing it via libp2p, obviously everything's encrypted with noise or TLS or whatever. So you have your peer ID is derived from a public key. So.
Mm-hmm.
And that's even true on browser to browser.
Mm-hmm. Yeah.
Right. Thank you. That's it.
Hello, Aging Brain. I have a question maybe to you. To relay, circuit relay. In some situations when there's no WebRTC possible in some hotels, yeah, for peer-to-peer connection in the browser, we have a WebSocket relay, for example, which takes from which creates a connection from each browser which is connected with me. For every browser which is connected to me, one connection, as I think, to the relay. Yeah. I hope this is right, how I understood this. The question is now, if this is right, if, for example, a mobile phone provider which has the same policy drops or cuts all connections from my browser to the relay, except one, is it possible to tunnel the other connections to the other peers through one to the single connection to the relay?
So Circuit Relay v2 is very different to Circuit Relay. The original Circuit Relay, you basically function as an open relay. So you could send all your traffic through the relay, and you could also configure it to be an active relay. That is, if you could dial like one node, your mobile phone would dial another node via the relay, and if the relay didn't have a connection to the remote node, it would open a connection. Which then, if you're an open relay like that, it makes you a vector for attacking other nodes because you're using these nodes, you're using the relay to dial the other node. Relay v2 doesn't allow this by default. If you want, you can configure it yourself to do this, but it's not the default configuration. So the idea of Circuit Relay v2 is that you're basically a public good, so anyone can dial your relay. You have a limited number of slots, and anyone can make a reservation to use one of those slots. And then other nodes can dial the relay, which will then open a stream to you. But you can't go the other way unless you configure it to do so. I think if you're in a very like adversarial network condition where you were using WebRTC and the connections were getting closed by the mobile phone provider or something like that, you might want to configure turn instead. So when you configure your WebRTC transport, you can use stun and you can use turn. We use stun for working out public IPs, and then turn will like you would fall back to turn to relay all the traffic via a turn server, but it would be kind of separate from the relay, like the Circuit Relay server.
So turn and stun works as an alternative to Circuit Relay or in parallel or as backup?
They do different things. So Circuit Relay allows two WebRTC nodes to exchange SDP packets, so they can make a direct connection between themselves. If they can't make that direct connection, then they can fall back to turn, which would then relay the traffic via the turn server. But you would have to configure your own turn server. It's not a feature of Circuit Relay.
Sure, thank you.
Any other questions? Come on, you guys. I know you want to know something.
So,
Yeah, whichever, doesn't matter. Sorry, I didn't mean to.
Hey, debugging. So there are two use cases where I found debugging to be really challenging with libp2p. One of these is
Which implementation of libp2p were you working with?
the Go one, but I would expect that to be the same in pretty much every implementation. I think the first use case is you do a provider record lookup, and then it fails, but it's not really a failure, it's just a lack of positive response. And you'd like to know why it failed. And then if you look at the current DHT lookup process, understanding why it failed is going to take a lot of time, because you're going to have to add logs everywhere, see what's going on, and it's really difficult to do in production. So you can do it in specific test setups, but in practice, this is one of the really big lacking areas for me in libp2p. So it's not really a question, but more an open question about what could we do better to solve that. And the second debugging question I have is somewhat related. In general, that's relevant for both libp2p and the DHT implementation on top. When you start an action on libp2p, say I want to open a stream or whatever, you'd like to know again why it fails, if it fails, and typically what I've done in the past is instrument the code to add logging statements, make sure they log with the Go context, and then I set something, a special unique ID in the Go context to track the caller, and then I track the logs separately, and then I aggregate the logs with the unique IDs for each call site, so that I can, for a given call site, understand what went wrong or what actually happened positively or negatively during this call. It's something that is not really easy to do with the current tracing event infrastructure, or at least I didn't found a good way to do it. But in general, again, for production-related issues, being able to have, I would say, solutions or hints on how we could look into this, and these are the two items that were on my to-do.
I think Droppo was going to help you out with that.
Yeah, I can answer for Go libp2p cat DHT. I had the exact same problem you had, and I implemented OpenTelemetry tracing, and I think it was merged. So now you can set up OpenTelemetry. It does the exact same trick you said of putting an ID in the context, and then you can export it to something like I use Jaeger, but there are many other tools like Grafana, and it works by creating visual spans. So you can have it's kind of like a call trace, but you create the spans yourself. And it still requires, if you want to deeply know why it didn't work, because all you did is get no answer, you still kind of need to know how the DHT work. But it's pretty easy to learn. It's going to show you oh, I did the first resolution of the bit, and I tried contacting that many peers. All of this failed. So I can show you this if you want after. And on Go libp2p, we don't have OpenTelemetry. It would be nice. I'm not a maintainer of Go libp2p, so I think someone else should answer this. But I really like open tracing for this. Yeah, you don't have, so you kind of have to write the thing once, but then it's very useful. And you can configure it in production so that you can add a flag to your request of oh, it didn't work. Now let me add the flag, do OpenTelemetry, because the problem is that there's a significant overhead depending on what you trace. So at least for cat DHT, I don't know when you did that, but now if you do OpenTelemetry, it should be very easy.
Well, maybe what I'd like to add is I understand what you're saying. This is what I did. And what I was trying to say is it sucks.
That's fair.
The thing is, it's as a developer, I make an API call. I'd like to get something from this API call programmatically that allows me to understand what went on in this API call. You know, if I have to do all this thing, tracing, collecting traces from a separate server and all this stuff, it's just so painful, really. So that is the question I was asking.
Thanks for the feedback. You know, the same pithy response that I have for you is patches are welcome. Encouraged even. I'm sorry that it's difficult. Yeah, the peer-to-peer programming by its nature is, highly parallel, highly unstable, lots of churn. Like it really is difficult at times, right? And yes, it's very useful feedback actually. One of you were going to say something?
I was going to say, it's like the ease and the difficulty of use is how much you engage with it. Like you can just stick console logs in for like the JS one. You can log the events from the progress handlers, and you'll get a nice way of seeing things really super quickly. Or you want the more interrogatable approach, then you use Grafana and OpenTelemetry and all that kind of thing. And there is more setup, but then your quality of results is going to be better. Like how much effort you want.
And also, if I'm not mistaken, the plan, or at least maybe for the Go libp2p implementation, is to start implementing error codes. So that was concerning the first request, so that you can identify what went wrong. For instance, why you didn't find something in a DHT, rather than the lack of answer, you would get just an error code. So I hope we can make things at least a bit better.
There's a spec for that, right? Did we write a spec for this? The error codes?
Not sure yet. So I think it's on the roadmap, but not sure if the work has already started.
Yeah, I know it's on the roadmap. I wasn't sure if it had actually been written down as a proposal yet. But that would help with that, because the idea is positively communicating error state.
There's also if you've dialed a remote node and you're doing some protocol stream stuff, and you send something that offends the remote node. At the moment, the remote node will generally just close the connection and just reset the stream, and you'll get no idea of what went wrong. Whereas the idea with the error codes is it will send you an error code telling you what you did wrong, and then reset the stream.
Yeah. Any more questions? Any more comments? More you suck? Can you hand him the mic so you have a question?
I mean, just an add-on question. I know KDST tracing works, but I'm just curious, do we support distributed tracing across the peers?
Do we support distributed tracing? Is that what the question is? Yeah.
So in the... No.
For example, I have peer 1 and peer 2. If you use, assume the two peers were communicating using libp2p streams and stuff, right? If you use distributed tracing, I can, on peer 1, this thing happened, and after that, a message sent peer 2, may this thing happened, right? So I will be able to easily understand the spans, look at the spans, and see this thing happened on peer A and this thing happened on peer B.
So the way I implemented it right now, I use OpenTelemetry, the Go toolchain library, sorry. So you can set this up. There are a few problems getting it working on a few protocols. The two problems are collecting the traces in one place. Right now, we have no way of, there's no libp2p way to collect traces. And the way I did it is by using the Boxo library and uploading to my own server. But that means that I have to configure this on my own application and on my own servers. So if I want to ask the traces on someone else's computer, so just nothing to do this. And the second thing is passing the trace ID. So the way OpenTelemetry works is you can create a span ID, sorry. So you can create IDs, and you can set children and parents. And so that means that visually, instead of having 10,000 events, it's going to show you a nice tree of everything that was done. And that works on HTTP. So because OpenTelemetry has, they call them propagators. And there's an HTTP programmers which use HTTP headers, and that works very well. I never tried it on libp2p over HTTP, but it should just work. If it doesn't, open an issue, it should be an easy fix. For something like the DHT, though, it's not using HTTP, so we would need to do a spec change to the Cademelia libp2p protobuf to add a OpenTelemetry trace ID, and that would allow us to pass the trace ID along. And so if you solve the two problems of like collecting traces from other people's machine, which is the harder one, and passing trace ID along, which is the easy one, it should work. In practice, in the case of Kademlia, you don't really need it because all the logic is in the client. The server is very dumb. And so you don't learn that much by tracing the server. But if you have a more complex protocol like a Potsides, that could be very useful, yes.
I'm just bothered about peers, which we have control of, right? So I'm curious to even contribute on that point because I'm building an L1 protocol and debugging something going wrong on a PubSub message, like it's very tough, right? So yeah, that's what I'm curious about. Thanks.
I think there was a talk yesterday about libp2p internals, and someone did a kind of an end-to-end demo where the traces all end up in Prometheus and Grafana. So I think there's a solution for it. I mean, if there's a video recording here, I'm assuming it will probably be available, accessible, that kind of shows how to do that. Well, I mean, what the useful aspect of, if you're familiar with Grafana SDK, is that you could see where those issues are coming from and like the timing that it takes, and you know, just where it's happening in code. It's got, you know, open telemetry compatibility.
Breno? Whoever's going to talk, please use the microphone.
Just basic, but I still haven't found an answer for that. If you have the network, you know, all peer-to-peer networks are overlay networks, right? In the end, you're gonna end up with physical connections, but in traditional networking, you can trace route and see the path, all the hops that are going from the source to destination. Can you do that in an overlay and peer-to-peer network like the one that is built with libp2p? Is it possible?
Can you use the microphone, please?
I guess the distributed tracing ideology solves it, right? If you're able to pass the trace ID to a different peer, and that entire thing will help us. I mean, we cannot get to the transport level, but at the application level, which is using PubSub protocol, any protocol which is built on libp2p.
The basic would be, would there be an equivalent tool like traceroute for libp2p if I want to just monitor how is those data moving? Could I follow it?
Well, I think the thing about like traceroute is that you're doing it at the network layer. So
Yeah.
with libp2p, that's kind of abstracted. So you're talking to a remote peer, but then the actual transport that you're using, it could be TCP, it could be WebSockets, which could be on TCP, it could be quick over UDP, it could, you know, so you would have to look at the multi-adder of the remote connection and then use whatever tool was native to that transport.
And also maybe to add to that, so for instance, if you're looking at the path from one node to another, or if you're looking for some content, say, in Kademlia, and you have to go through multiple hops, your packet isn't going through multiple peers at a time. So first, you're going to query the first peer, get the answer, and then contact the second peer. So you're not traversing multiple hops.
You know, I think I haven't implemented this, but I would think that there's some way within code, if you're making a call, perhaps there's something at the application layer that you could pull and then push it into the trace debug that it ends up that'll end up in a database where you could look at the metadata where that's going to be visible, I would think.
I guess the only time you would be getting multiple hops is if you were going via a relay server.
Yep.
But yeah, for the most part, everything is a direct connection to the remote peer. So.
I got a follow-up question on the discoverability and scalability of things. Like with libp2p, does that mean that, let's say you hypothetically have a million nodes online? How do they do all those million nodes get propagated to each client so that they could discover each other, or like what limit have you hit with the amount of nodes that could communicate with each other and find each other?
That's kind of what Kademlia is about, right?
Yeah. So for peer routing, usually libp2p uses the Cademia DHT, which means that you only need to keep so a logarithmic number of peers inside your routing table, and in a logarithmic number of steps, you'll be able to reach anyone on the network. So you don't need to remember and know every single peer in the network. You just need to know the ones that are close to you in the Cademia XOR key space. And then you'll be able to route to any peer you want to reach.
I can have a meta question on the OpenTelemetry discussion. It seems to me that like multiple people in the multiple implementation in the ecosystem are using OpenTelemetry. I just built Rust libp2p recently, and I saw it download the OpenTelemetry package. I wrote some code myself to do that in Go, but we don't really have a. It's not even part of the libp2p spec. It's just that like people in the libp2p community seems to like OpenTelemetry for debugging purposes. And should we make efforts in protocol to allow to pass these kinds of debug information? So for example, like the gentleman behind me was saying, in the PubSub protocol, passing traces between in PubSub messages, have an optional field for this. Is this something that when designing spec, we should think about as a community of like, hey, OpenTelemetry is very useful debugging tool. Should we give it a more forward place and just like, hey, people like it and they implement it by chance?
I think it's an interesting one. Like I think OpenTelemetry is great, but there are certain use cases for libp2p where it's not a good fit, like in browsers, for example. So you might not want to make it specifically OpenTelemetry, but definitely the being able to pass like metadata about the request that you're making is an interesting one. Like the libp2p over HTTP talk earlier, for example, because everything's an HTTP request with headers and that, these are extensible like really easily. So a mechanism like that for most of like the protobuf kind of based protocols would be pretty interesting, yeah.
Anybody else?
I'm just to comment on what you just said. This is what's specifically I used to do for HTTP applications. So on the server side, the response would set a specific header to say, hey, here is some debugging information about this request. And that is exactly the kind of thing that I would love to be able to build on in a libp2p implementation. But it's tricky. And I would love to be able to come up with a patch to do this. And just an API that does this in a generic way is not something I know about.
Well, the first thing to do would be to open an issue on the specs repo to discuss it, and then people will propose ideas, and everyone will discuss it, and then hopefully a good idea will bubble to the top.
Will do.
Thank you. So there's JS, Rust, JVM, and there's a missing C, and I'm wondering if the
C++ guy two rows behind you.
There's a C++ maintainer right behind you. He's the project manager. He keeps assuring me he knows nothing about code, but I see commits from him in GitHub, so I think he's lying.
I'm wondering, is there a good up-to-date implementation for .NET that would be compatible with this as well?
There is 100% a well-maintained and actively maintained .NET implementation.